All right, can we start? How many of you are there? So when you're ready, call me. Let me have the class.
Yeah. I'm here.
How many of you?
All in class.
Yeah. Inform the rest to join the class.
I show you. Yeah.
Inform the rest to join the class. We are starting now.
Inform the rest.
The class have not started. What did you say?
Yes.
Okay. So we are looking at the first topic in physics, which is measurement. So yes, we'll look for today, if time permits, we'll look at the first out of the four listed here. We are going to look at the first three. I hope you can all hear me clearly.
Yes, sir.
All right. So we look at classification of physical quantities, definition of standards and units, dimension and dimensional analysis. So as introduction, physics is as a branch of science deals with nature and the relationship between matter and energy. So it is a natural science that is based on experiment, measurement, and mathematical analysis with the purpose of finding physical laws that governs everything in the universe. So everything we are seeing around us in the universe is governed by the laws of physics. The laws of physics. And this law does not just come like that. When someone hypothesizes or have an inspiration or come up with any thought, it is subjected to experiment. And over time, the experimental findings, the result of the experiment, if it is consistent over time, then that becomes a law. So that is how laws are propounded.
No, the meeting that we did, the meeting of on Saturday,
Yeah.
we didn't see them. We didn't see them on Sunday.
My wife on Friday, so they gave us a deadline of yesterday. Submit our medicine. So she went to my office to even yesterday Sunday. Seems like only online.
He told me, when you listen there,
What is that?
Sorry, please, everyone, off your please. Just please.
Offline. What am I on? Mute it.
I'm thinking, as I'm talking there, that day when I return home, I can see that this is the done. I see your wife. So bring them for me.
Yes. All right. So now, sorry for the time. So when experiment is carried out in physics, the way it is reported is in two parts. The two parts are the numerical part and the alphabetical part. I want everybody to send a message of your name and department and matric number as attendance in a chat. Just send your name, matric number, and department, which will serve as attendance. Also, I have sent a YouTube link to the platform. So after the class, you can go to that link and watch the class over and over again. So all reports are represented in two parts, which are numerical and alphabetical. The numerical part tells us of the magnitude, the size, or quantity of whatever we have measured, while the alphabetical part tells us the specific quantity that has been measured. So the example there, we see 20 kg. Just looking at that value, 20 kg, tells you that this is mass that has been measured. This is mass that has been measured. If we write only 20, it is just a number and it does not specify anything. There is no way anybody can know that this is mass that has been measured. That is the essence and importance of writing the alphabetical part, which we often called units. So if you do measurement and write the value, the quantity, and without writing the unit, it is as if you have not done anything because it is not specified. So note that is why in physics, unit is as important as the answer that you have gotten. So categories of physical quantities. Physical quantities are anything that can be measured in physics. That is physical quantity. Whatever that can be measured in physics is referred to as physical quantity. And there are three categories of physical quantities, which are the fundamental or the base quantity, the derived quantity, and the supplementary quantity. Fundamental or base quantity, the derived quantity, and the supplementary quantity. So what are fundamental quantities? They are quantities which are distinct in nature that cannot be defined by other quantities, but upon which other physical quantities are derived. They are 7 in numbers, which are mass, length, time, current, temperature, amount of substance, and luminous intensity. These are the fundamental quantities. Every other quantities are derived upon these 7 fundamental quantities. So they are listed here as well. Now, the next category of physical quantity is called the derived quantities. Like the name sounds, derived. They are quantities are based on other physical quantities. Quantities that depends on other physical quantities, but not just other physical quantities. They depend solely on the fundamental quantities. They are derived by multiplication or division of two or more fundamental quantities. So when I multiply two fundamental quantities, for instance, mass and length, that is mass and length, if I multiply them together, that will give me a kilogram meter. So that is a derived quantity. Kilogram meter, that is a derived quantity. If I divide meter and time, that will give me meter per second. That is velocity or speed. So that is also a derived quantity. So examples of derived quantities are listed here. We have displacement, we have speed, we have velocity, we have acceleration, we have force, we have energy, density, moment, power, work, momentum, and pressure, and many more. So here you have the list in a table. So the third category of physical quantities are the supplementary quantities. Supplementary quantities. They are geometrical quantities of circle and sphere, such as plane angle and solid angles. So the table there shows the two supplementary quantities that exist, which are plane angle and solid angle. Now, back to units. A unit is a physical quantity that can be counted or measured using standard size. Unit as used in physics refers to the standard measure of a quantity. Standard measure of a quantity. The quantity used as a standard for measurement. Quantity used as a standard for measurement. That is what a unit is. Now, characteristics of standard unit. A unit selected for measuring a physical quantity should have the following properties. One, it should be well defined. It should be well defined. It should not change with change in physical condition like temperature, pressure. When temperature change from lower temperature to higher temperature, the unit is not expected to change with change in temperature. So that is why we have 0 degrees Celsius, we have 100 degrees Celsius. So it should not change with change in physical conditions. It should be suitable in size. It should be suitable in size. It should not change with place or time. It should not change with place or time. It should be reproducible. It should be internationally accepted. These are characteristics of standard units. Now, this unit, just as we have physical quantities categorized into 3, which are fundamental quantities, derived quantities, and supplementary quantities. We also have units categorized into three, which are the fundamental units. Fundamental units are units of fundamental quantities. We have the derived unit. Derived units are units of derived quantities. And we have the supplementary units, which are units of supplementary quantities. Now, system of units. There are basically 3 to 4 systems of units. The first one is the CGS system of units. C for centimeter, G for gram, and S for second. CGS. Centimeter, gram, second unit. The second one is the FPS. Foot, pound, and second. This is a system of unit that is used by the British system of unit. For instance, when you go to market to buy clothes, they measure the clothes for you in yards. When you want to buy a shoe, they will ask how many, what is the size of your shoe? That's feet inside in terms of feet. Foot, pound, and second. That is British system of measurement. Foot for length, pound for weight, and second, that is for time, universal. Then the third system of unit is S, meter, kilogram, and second. Meter, kilogram, and second. And that is also IS unit. That's why I said 3 to 4 system of unit. The IS unit or SI unit system is the same as the MKS, meters, kilogram, and second. Meter, kilogram, and second. That is why you oftentimes you will come across problems in physics that warrant you to convert from one system of unit to the other. Sometimes you are given questions and some of them are in centimeter, some of them are in kilogram, and you have to convert the centimeter to meter, and the ones with gram to kilogram. However, if the system of units given to you in a problem are in CGS, that is, all the parameters here are measured in centimeter and gram and second, you may not need to convert to meter and kilogram, except it is specified. But if there is a mixture of the units are not uniform. You have centimeter, you have meter in the same question, you have gram, you have kilogram in the same question. You have to convert all to the SI unit system. The SI unit system is the same system of unit for MKS, that is meter, kilogram, and second. So advantage of SI system of unit. What are the advantages? Why do we require SI system of unit? One, it is coherent system of unit. It is coherent system of unit. That is, the derived units of a physical quantities are easily obtained by multiplication or division of fundamental quantities. That is number one advantage. Number two, it is a rational system of units. Rational system of units. It uses only one unit for one physical quantity. That is, for energy, for instance, all forms of energy, the unit is joule. Whether heat energy, light energy, kinetic energy, potential energy, whatever forms of energy it is, the unit is the same, that is joule. And the third advantage is it is a metric system of units, that its multiples and sub-multiples can be expressed in power of tens. So for instance, if I have 1,000 joule, I can write it as 1 kilojoule. 1,000 joule is 1 kilojoule. Then if it is 1 million joule, I can write it in terms of express it in powers of 10 as 1 megajoule. 1 megajoule. So that is why it is a metric system of units. So here we have a list of metrics SI prefixes ranging from 10 raised to 24 to 10 raised to minus 24. 10 raised to 24 to 10 raised to minus 24. Now, dimensions. Dimensions of a physical quantity are the powers to which the fundamental quantities must be raised to represent the given physical quantities. The power to which the fundamental quantities must be raised to represent the given physical quantity. You should note that the powers to which the fundamental quantities must be raised. The fundamental quantities, notably, which are the MLT, mass, length, time. The powers to which they must be raised to represent the given physical quantity. So, for instance, we have force, which is mass times acceleration. Mass times acceleration. So if you write down the fundamental dimensional formula of force, that is MLT minus 2. MLT minus 2. So M is raised to power 1, L is raised to power 1, and T is raised to power minus 2. So the powers to which they are raised, M1, L1, T minus 2, those are the dimensions. So the dimension for force are 1 in mass, 1 in length, and minus 2 in time. Now, dimensional analysis. Dimensional analysis is the use of a set of units to establish the form of an equation. The use of a form of units to establish the form of an equation, or more often, to check the answer to a calculation as a guide against many errors. We can also define dimensional analysis as a method of analysis in which physical quantities are expressed, in terms of their fundamental, is often used when there is not enough information to set up precise equations. So those are two definitions for dimensional analysis. What are the applications of dimensional analysis? Number one, to check the correctness of a physical equation. That is, when you are given an equation, how do you know if the equation is correct or if the equation is wrong? You can use the dimensional analysis method to check if the question is correct or the question is wrong. That is number one application. Number two application is to convert a physical quantity from one system of units into another. One system of units. For instance, we have three systems of units I mentioned: the CGS, the FPS, and the MKS. So conversion from one system of units to the other. That is another application of dimensional analysis. Converting whatever you are given in CGS to MKS or MKS to CGS. So that is another application of dimensional analysis. The third application is to derive relationship between physical quantities. To derive relationship between physical quantities, how physical quantities are related. How physical quantities are related. To derive a relationship between physical quantities, how physical quantities are related. So we are going to the next page here. We have dimensional formula. What are dimensional formulas? They are expression along with powers of mass, length, and time, which indicates how physical quantities depend upon fundamental physical quantities. So for speed, speed is distance over time. Distance is L, measured in meters. Meters. And then over time, measured in time, T, seconds. So if we express that in fundamental or dimensional formula, we are going to have LT minus 1. LT minus 1. So by dimension, for speed, L, 1 for L, that is length, and minus 1 for time. So here we have a list of physical quantities, their formulas, and their dimensions. Physical quantities, their formulas, and their dimensions. So you need to study them and master them. Very important. So we have up to 22 of them listed for you. Now, the principle of homogeneity of dimensions. The principle states that the dimension of all the terms on both sides of an equation must be the same. The dimension of all the terms on both sides of an equation must be the same, must be the same. For instance, if you recall your equation of motion, let's say V is equal to U plus AT. V is equal to U plus AT. So look, picture V on the left side is equal to U plus AT on the right side. So by this definition, it means that what you have on the left side, that is V, the dimension of V must be equal to what you have on the right side, the dimensions of U plus AT. So that is what homogeneity principle of dimension is telling us, which means that if they are not equal, it simply means the equation is wrong. And that is one way of testing or checking if an equation is correct or if an equation is wrong. If the units, if the dimensions on the left side or on the right and on the right side, on both sides of the equation are not balanced, it means that the equation is wrong. It's not correct. So let's look at that example stated here. S is equal to ut plus half at squared. Now, one thing you need to know about this is when you are checking if an equation is correct or wrong, you may not consider constant terms and values, constant terms and figures. Like here we have 1/2. 1/2 is a figure. You may neglect that. But if it is raised to power, that is t squared, that you must consider it. But if it is just the 1/2 you have there, you can ignore that 1/2. So bringing that previous equation to test, S is equal to ut plus half at squared. How do we test if this equation is correct? So what is the unit of S? S represents S is a symbol of length or distance. So the unit of S or the fundamental formula for S, distance, is L. So that is why you have S is equal to L. Then for velocity, which is U here, velocity is L t minus 1. And then time is t. Together, while A, acceleration, is L t minus 2. L t minus 2. So if we put the equation together, as you can see there, ut is L t minus 1 and t plus at squared, you have L t raised to minus 2 for acceleration and t squared, which is t2. So if you simplify that expression, you are going to have L raised to 1 plus L raised to 1, which is, of course, the same thing as the dimensional formula for distance. Distance is L. So ut gives us L, at squared gives us L, which implies that the equation is correct. The equation is correct. So here is another example. We have V is equal to U plus AT. V is equal to U plus AT. So if we write the dimensional formula for V, that is LT minus 1. And the dimensional formula for U, which is LT minus 1 as well. Then the dimensional formula for A and T. A is LT minus 2 times T, which is T. So if we simplify that, we have on both sides LT minus 1 is equal to LT minus 1 plus LT minus 1. So looking at that equation, it simply means that the equation is correct because on both sides of the equation, we have the same dimensional formula. We have the same dimensional formula, which means that the equation is correct. So that is how to test an equation. Do you have any questions so far before I proceed? Any questions so far before I proceed?
No, sir.
All right. So let's look at this example. The example says, what are the dimensions of A and B in the expression f is equal to a square root of x plus bt square? You are given an equation. F is equal to a square root x plus bt square. You are asked to find A, the dimensions of A and B. Now, according to the principle of homogeneity, we can only add two quantities if they are of the same unit. We can also equate two quantities if they are of the same unit. We can also subtract two quantities if they are of the same unit. If they are not of the same unit, you cannot add them. For instance, you cannot add acceleration and distance. You cannot add acceleration and distance. You can only add acceleration 1 and acceleration 2. You can only add distance 1, distance 2. You can only add velocity 1, velocity 2, or subtract velocity 1, velocity 2. You cannot add velocity plus distance. So that is the principle of homogeneity. So bearing that in mind, to find A and B, we have to equate each of those parameters to what we have on the left side. So we write that f is equal to a square root x as one equation, and we also write that f is equal to bt square. So now we have two equations. F is equal to a square root x, f is equal to bt square. So if f is equal to a square root x, we can make a the subject of the formula by dividing through by square root of x, and that will give us a to be f over square root of x. Similarly, we can also have b to be f over t square, f over t square. So when we do that, the next thing to do is to write down the dimensional formulas. Write down the dimensional formulas for f and the dimensional formula for x. Remember in the equation that f is force and x is distance. So the dimensional formula for force is m l t minus 2. m l t minus 2. While the dimensional formula for distance is l. But because this distance x is in a square root, so we can write that that is x raised to power half. X raised to power half. So if we now change that, we have mlt minus 2 over l raised to power half. So if we move the l raised to power half up, that will be l raised to minus power half. Minus power half. And since we have l at the numerator, which is 1, 1 minus half will give us what? Half. So that is why we have m l half raised to half t raised to minus half. So A is equal to ml raised to half t raised to minus half. Then B is equal to f over t square. F is mlt minus half Then t is raised to 2, which is t squared. So if we simplify that expression, we have b to be ml t raised to minus 4. So that is the first application of dimensional analysis. That is how to check the correctness of an equation. So we have been able to do 1 or 2 examples to show that when an equation is given, you can apply dimensional analysis method to check if the equation is correct or wrong on the principle of homogeneity. Now, the second application is to derive another form of physical equation. How do we derive another form of physical equation? So here we are given an example to find the expression for the time period of a simple pendulum, which depend on its length, mass, and the bulb. All right, so I think we can stop the class here. We'll meet again because of some of you are talking about data. So, and the school said we should not exceed between 30 to 45 minutes. So let me stop here.
My friends. Sir, can I get the slides?
But the link, I sent a YouTube link. So you can go back to that. You can click that link. It will take to the YouTube where you watch this